So my name is Andrew Betts. I founded a company called Nasanka about 8 years ago, 2003, and for most of that time, since that time, we've been building web applications, a wide variety of different things for a great variety of different clients, really. And in 2006, we started working with the FT, creating some live chat applications, some blog applications for them, and we've done a great many things since then. And in 2010 we started working with them on an HTML5 web app project. The idea being to replace their existing native iPad or iPhone apps with a single solution which will also deliver the same experience to Android, BlackBerry, and ultimately other platforms as well. So I'm going to start by showing you a quick video of the app in action for anyone who hasn't seen it. And then we'll talk about some of the reasons why you might want to go down this route and the technical challenges which we faced. So there is a bit of audio. So this is a mock-up, but it's demonstrating things that you can do in the app for real. So it starts off looking relatively like an ordinary website, but we can swipe side to side between sections. We can use a section navigator at the top to jump to any particular section we want to see. And because this is a web app, you can obviously switch to any other device. It's a slightly different layout on the Zoom because we're adapting to a different screen size, and we're also putting in the Android action bar because Android users will be familiar with that. And all the time that we're doing this, all the time that the user is navigating through the app, we're downloading content continuously in the background. So that content is being downloaded using multiple AJAX requests that tightly compress and batch that information into as few requests as possible, so that when we go offline, as we just did then, we can keep clicking on content that we haven't read yet, and the app will still be able to serve it to us even though we're offline. All these devices we're seeing scrolling through the gallery in a very generation game type way are all supported devices. This large image, for example, that would be an image that we downloaded for offline viewing. We didn't have to download it when we actually went into the page. Markets data as well as the captions, ready to view the instant you push the button. So it very much has the feel of a native app that is built using native technologies. And if we go back online, it's somewhat a playbook, so slightly different UI, and the app will automatically detect we're online and refresh itself. We're not limited to just large screens, we also deliver precisely the same code base to all devices, so we don't do any user agent sniffing on the server side. All the layout adaptation is done based on decisions made on the client. So we're doing that using a combination of media queries to get to a kind of target layout, target range, and then we do various adjustments using JavaScript. So we'll start with why you want to do this rather than creating a series of native apps for each platform, because creating that is quite hard. So, and I think to do that we need to look at a little bit of history. Not much history, we'll skip about 9 million years and start with the web. So the web was a really good idea. It didn't just provide us with an excellent technical platform, but also a number of really good things about the way it's organised and controlled, which have contributed to its success. So things like the fact that we can have different systems using different technologies that can work together using an agreed protocol which is maintained by the community. And that intrinsically means the web has kind of built-in longevity. It's something that, as a business, we can invest in without some of the risks that would be associated with taking on technology that might have more of a shelf life. And obviously, we're sitting here in 2012 with the benefit of hindsight. We can see how successful the web has been over that time. It's given us things like cat a day today, which improves famous masterpieces using cats. So, the web has transformed our lives, and we recognise that the way that it transforms our lives is so important that we need to have access to it wherever we are and whatever we're doing. So, for quite some time now, a lot of people have been working quite hard on getting that experience to us on the move. So some of the attempts, the early attempts, were not quite so successful. Who still uses WAP? 2, 3. There's only one in my group still.
That's my phone.
But I think we can safely say that WAP was never a mainstream technology. At least in the UK, apparently it was amazingly huge in Japan. And then in 2001, something quite interesting happened because BlackBerry took a look at the situation and said, well, we can't deliver this using the hardware and software that we have today. So what we'll do instead is we'll just take the application, the use case that you really, really want, and we'll just make that work. And so for quite a number of years we had mobile email. But we kept working on it, and of course in 2007 with the iPhone, Apple had essentially solved the problem and provided a user experience of a full, proper mobile web that everyone, mainstream users can get behind and can use. But interestingly, it took them less than 12 months from there to tell us that we should pull a massive U-turn and build native apps instead. Which is quite interesting because from my wholly biased viewpoint, looking at apps, they don't stack up terribly well against the web. They typically use proprietary technologies that only work on one platform, are designed to fulfill a very specific niche that is less well served by web technologies. They have accessibility problems. They are very tightly controlled and regulated by the operator or the device manufacturer, the owner of the ecosystem. In the case of iOS, Apple. In the case of Android, typically Google. So, why do people build them? Well, there's obviously some benefit that we get from native apps, or got from native apps that we couldn't get from the web. And to define what that is, I'd like to explore what exactly is an app, which is a question answered in the previous talk, so I'll give my answer as well. I see an app as two things. It is adaptive design, on the one hand, the ability to fill and use to its fullest extent the screen that the user presents you with. So, commonly, as was covered before, major publishing sites, including the FT, including the BBC, CNN, virtually all major news sites that you go to today will look pretty much the same. And on a big monitor like most of us have now on our machines at work and at home, you get huge amounts of white space to the left and right of the main content. Because the publisher is choosing not to be flexible, not to be adaptive. And that kind of worked until apps came along and perfectly and beautifully filled the screen and were so perfectly tailored the end user had available in terms of screen area. So the challenge for HTML5, which of course doesn't have the constraints of native apps in terms of the variety of devices that can be used to view it, is to adapt to a much larger variety of screen sizes and always deliver something that looks as though it was perfectly designed to fit your screen. The other half of it is an adaptive interface. Now, you saw the Boston Globe example earlier. Boston Globe have tackled the first half of this problem, creating an adaptive design that fits the screen, whatever size that screen is, although it does actually have a maximum width. But part of it they haven't chosen to tackle is having an adaptive interface. Their website fundamentally still assumes that you have a keyboard and mouse, and that you're using those input devices to navigate the site. So devices that offer a touchscreen have to essentially polyfill that by recognizing the individual links, putting touch targets on them, and kind of, you get there, you kind of survive. But it's not a native app. It doesn't look like a native app, it doesn't feel like a native app because it's not as responsive, and you have to really pick at those really small links, which the site assumes you've got a mouse to click on. So being adaptive is more than just about layout and size. It's about thinking about how the user is actually going to interact with your website on their chosen device. Now, until about 2 or 3 years ago, we only cared about one of these input mechanisms, mouse and keyboard. Now we care about two, mouse and keyboard, and touchscreens. But that's by no means the only input mechanisms that have actually been implemented. BBC iPlayer has an excellent TV remote optimised site, bbc.co.uk/iPlayer/big screen, and that's the version of iPlayer I get when I go to iPlayer on my Blu-ray player at home. It is just a web browser inside the box. We already have web browsers inside other boxes as well. Xbox, PlayStation. These devices have web browsers inside, and they are controllable using games console controllers. And because we have the Kinect, which hooks up to the Xbox 360, you can actually potentially use 3D motion gestures to control web pages. And these technologies all exist today and could be used to control websites. And in the future, there will be more of the technologies as well. So it pays to back a technology which could potentially support all of these, rather than one that gives you a really good experience with just one of them. So the bottom line is people built apps because their websites weren't adapted to this new requirement to support touch optimized input. So this new technology gave us a solution that produced a really good user experience. And in fact, it pioneered a number of completely new interaction styles. Things like overscroll to reload, swiping between panes of content, context-sensitive large touchable buttons, and pinch to zoom. All of these kind of interaction techniques didn't exist before touch came along as a way of interacting with the web. But this kind of adoption of native apps is questionable as a business strategy. This is actually some research which I love quoting from Nielsen Journalism Lab, where they looked at tweets coming from the Daily iPad application. Now the Daily is a really big, expensively run operation that produces an iPad-only newspaper, daily newspaper. It's owned by News International, costs about $10 million US a quarter to run. And over this period that Nielsen were looking at, the number of tweets coming from that app is gradually declining. In fact, at the end of the period that they were looking at, it was down to less than 50 a day. So, and I'm not saying by any means that all native apps are ultimately destined to fail, but if you put all your eggs in the native app basket and this happens, then you're screwed. So backing a technology where you can quickly change your focus and adapt to where the demand is ultimately valuable. So the question really is, can't we just create these great user experiences using that more open, more adaptable web technology? And the video I showed at the beginning should demonstrate that we can. So some of the technical challenges that we came across in building this include dealing with the adaptive layout and creating layouts that are quite difficult to do using the CSS technologies that we have available today. Creating these new navigation and interaction experiences which didn't exist previously. Making the app work offline. And completely rethinking our back-end architecture, because the way the front end interacts with our server application is completely different from the normal model of the website. So I'm going to attack a few of these in more detail. Newspapers have traditionally, for about 200 years anyway, formatted content pretty much like this, in narrow columns of text. And when newspapers went digital, they changed this. They adopted a more web traditional model of having a single column of content that scrolls vertically. So when newspapers moved onto tablets, there was an opportunity there to rethink this and consider the kind of setting in which the paper would be read, and work out whether that single scrollable column was appropriate for that usage model. And we decided that it wasn't, and that people holding an iPad in a relaxed setting are more likely to feel like they're interacting with it like they're just reading a print newspaper. And in that situation, narrow columns of text has been proven over a very long period of time to be the optimum way of presenting content. The problem is, it's fundamentally quite hard to do this in CSS. CSS3 offers us a columns feature, but it is incredibly basic and can't handle even the rudiments of doing something like this, where we have a title spanning 2 out of 3 columns, we have some fixed position inserts that we have to put at the top of the second column, but we don't know where they go in the text, because if the user increases or decreases their font size, the point at which the text wraps from column 1 into column 2 will change, but the positioning of those fixed elements should stay the same. So that's a really hard challenge to solve using CSS. And at the moment we solve it using JavaScript. So we actually position the content entirely in column 1, we then find the wrap point, duplicate that wrapping paragraph, and then take the remainder of the content and move all of that into column 2, apply a negative margin to the first paragraph so that we hide as much of the paragraph in column 2 as is showing in column 1. And that enables us to quite efficiently wrap all the text into multiple narrow columns. We're actually working on open sourcing that library very soon. Another challenge is to do content balancing. Here's an example of an element that perfectly fits the width of the screen. This is what we call a video midriff. So you've got 4 videos there, and it's in a gallery. So if you tap these little arrows, then it'll scroll through to another 4. And it looks as though those 4 videos, we've chosen the size of those videos because we know how wide the device is going to be, but we don't. We fundamentally don't know how wide the device is going to be, so we have to adapt. But you will never see half a video here. You'll always see an exactly perfect number of videos that exactly perfectly fits the width of the screen. We do that by, first of all, reducing the size of the problem by taking the dimensions of the screen and putting it into one of 4 size categories. And those size categories will then affect broadly the layout we choose to use. Then within those categories we can make minute adjustments to deal with variations in screen size within that size category. Another challenge that we have is swiping between sections. So this is dealing with that completely new interaction model of the user actually swiping laterally between content. And we do this by having 3 completely pre-rendered pages in the DOM, in divs that sit side by side. We listen for touch events. Now the touch events that are now available in browsers that support Touch API are onTouch Start, onTouch Move, and onTouch End. It will give you an array of all the current points at which the fingers are touching the screen, so you can detect multiple touches as well. You can detect things like the order in which the fingers touch the screen. And for our purposes, you can detect things like the speed at which the user is moving their finger across the screen. And that's really important because if I touch down, move, say, 1 centimetre across and lift, and I do that slowly, then we'd expect the content to track my finger as it was moving, and then when I release, for it to gently roll back to where it was before, because I haven't moved far enough. I haven't reached the point at which it will roll over to the next screen. But if I do that exact same motion fast, then I'm actually flinging the content, I'm giving it momentum, and we should interpret that to be my intention to actually move to the next section. So there's an enormous amount of logic that you can apply to interpreting what the user intended to do with that gesture. And the only real easy decision to make here is, whilst the finger is on the screen, you want to, as far as possible, keep the content in sync with what they're doing. But as soon as they lift their finger, you've got to make a decision about what they intend that content to do now, because they almost certainly don't intend it to just stop dead. So you have to work out where it's going from now on. Like, for example, will you support flinging multiple pages? So if I fling really hard, can I go all the way around the carousel and back to the beginning without touching the content again? In our case, we don't. For technical reasons, and also because we think it doesn't make sense in context. You can't fling more than one section. So no matter how hard you try and get to the markets data section, you can only go one section at a time, and you'd have to swipe 6 times to get there. Another issue that we've been dealing with in terms of interaction is the speed at which the browser recognises click events. So in native apps, every touch evokes an instant immediate response. It feels really responsive. In the web browser, you possibly don't notice because you feel like you're in a different interaction mode, you're interacting with a website. But if you felt like you were interacting with an app, you'd probably find the experience really slow, because it actually takes 300 milliseconds for iOS to convert a touch into a click. The reason is because it's waiting to see whether you're going to double tap. It gives you 300 milliseconds to turn that single tap into a double tap, which would cause it to zoom the browser in. But if you set a meta tag constraining the viewport size, you're telling the OS you don't want this site to be zoomable, then you're essentially saying we're not going to use that double tap for anything. So why do we need to wait this extra 300 milliseconds to make our website seem really slow? So we've created this small polyfill with FastClick. It's available at sanka.net/fastclick. It's already open source, and that will automatically turn a touch start event, which is fired immediately, into a click on the underlying element, and that enables us to respond much more quickly to touch events. Incidentally, in the BlackBerry playbook, you don't need this. You can set a meta tag that says, my website knows what it's doing, please go out of the way and give me all the events immediately. And it will do that, which is great. So that brings me to possibly the most difficult challenge of creating this kind of app, which is to make it work offline. Just out of interest, can I see a show of hands who has created a website that works offline? This is still a really very new thing, and not very many people are experimenting with this yet. But it broadly breaks down into 4 sort of sub-challenges. One is to make the app launch offline. So if we start with a completely empty browser and we go to the URL, and we're not connected to the network, how do we get the web page to load? And then we can dive into more getting the content to be there offline. So the FT is publishing new editorial content all the time. On an average day, there's around 1,000 articles which we want to make available to the user to read offline. 1,000 objects that we want to make available, including images. So we want to come up with some way of turning that over without having to continuously re-download everything all over again. And also analytics. If somebody's actually interacting with the app, that's valuable data that we want to capture about how popular various articles are. And normally that's the kind of thing you would capture in something like Google Analytics. But you simply can't do that if they're not connected to a network, and you can't capture that data in real time. So, looking at a few of these things in turn, the first challenge is booting. This is a completely new concept to most web developers, that your page needs to go through some kind of boot process. But this we found is the best approach to creating something which doesn't break the internet in its attempts to make itself work offline. So it's tempting to create a page that just contains a single script tag and nothing else. And we say that's your starting point. We cache that. That's easy to cache. We're never going to change it. And then we'll take it from there. But of course, that means your site has one URL and no content, which means you're not going to be very accessible, and you're not going to be very crawlable. And also you're not going to be very bookmarkable either. So using a bootstrap approach, we can still deliver pages of content in a conventional way, but we can then use bootstrap code, inline JavaScript within the page to cause the page to upgrade itself, essentially, by loading additional resources from local storage, local cache, to turn itself into an app. And then everything from there on can happen within that single page context, and we then don't need to do any further browser refreshes. And that also means that we can keep URLs. We can use the JavaScript history API that people were seeing earlier on to update the URL in the address bar. And if you were to refresh and try and request that URL from the server, you would get content for that page. So the server knows about all the URLs on the site and it can deliver content for each one of those URLs. But once it gets to the client, we can then use that page that we've created to then create any other page. So we're now So there's three technologies that you can use to help you solve this offline problem. The first is the application cache, the HTML5 application cache. And this is your only choice initially because the other two are both JavaScript APIs. So you're going to need to be in a web page and have JavaScript running in order to access it, which we don't initially because we don't have any pages at all. So to load a page when we're offline and in an empty browser, the only resource that we can rely on to do that is the HTML5 application cache. However, it's a bit ropey and we use it very sparingly. It's also extremely annoying because if you list 100 files in your app cache manifest, which is the file that the browser downloads that lists all the resources you want to make available offline, it will then go ahead and download all 100 of those files as quickly as it can, slowing down the user's interactions with the app. Your app will seem less responsive whilst the browser is going and doing all of that downloading. Added to that, if you change any one of those resources, even just a one-line change in one CSS file, the browser will then re-download every single resource in the manifest. It can't do a single file update. It can only replace the entire contents of the cache. And if any of the files fails to download for any reason, it will get rid of all the ones that successfully downloaded and revert to the previous version it had in cache. So even if you made a change to one file and it was a one-line change and the browser successfully downloaded the updated file, if it didn't manage to download one of your files that didn't change, it will get rid of the file that did change and you won't have that change saved. So our policy on using the application cache is put as few things in it as possible. Keep it really, really neat. And also put things in it that we're not going to change very often. So we use it for fonts, sprites, splash screen images, and one single Bootstrap page, and nothing else. So the things we don't use it for, which is quite important, is JavaScript, CSS, and content, which are the three things you might think you put in the app cache, but we don't put any of that in the app cache. We put those things into local storage because we can then update them individually. And these are the things we want to be updating all the time. The other two technologies we have are local storage, which I've mentioned a couple of times, which is a key value store that's available as a JavaScript API. It's quite fast, it's quite reliable, and it's worth using as much as you can. There's also a local database, which is either SQLite or IndexedDB, depending on which browser you're using, and that's useful for storing indexed content, things like articles, images, anything that you want to search for rather than just look up by key. And rethinking the back end, well, we saw Twitter as an example earlier of a site that does a lot of Ajax, and I think one of the innovations that Twitter has made recently, which is quite significant, is they rethought their whole API. Initially, their API was quite a sort of add-on, built for third-party developers, not really built with themselves in mind. Now, the Twitter API is at the core of everything Twitter does. So the Twitter iPhone client I use, the Twitter desktop website, these are API clients. They are just using Twitter's API in the same way that a third-party developer would. And as a result, Twitter's API is now so much better, so much more standardized, so much more robust. So if you think about building your API as building a framework which you might ultimately offer to third-party developers as a way of integrating with your app, then you'll probably build a more standard and more robust API that will benefit you as well when you're implementing your HTML5 front end. And I'll just finish with some unresolved problems. Some of the things that still bug us and which we're still working on. SSL, this is something which I've been going on about for about a year, but I don't think there's ever going to be a solution to this. The FT app, obviously there's opportunities to subscribe. It's an expensive product. You're going to pay £300 on a credit card. which we're going to ask you for that credit card number, and we're going to tell you that it's secure. But there's no independent endorsement that that connection is secure. You believe it's secure because we tell you it is. And that's kind of an anti-pattern when it comes to building responsible websites. We've been in the community has sort of been teaching users for about 5 years now that they shouldn't believe websites that tell you that the connection is secure. They should look for indications in the browser itself. Because there's no browser, there is no other indication. So we just have to bang the drum and tell them it's secure. Social media integration has proved to be a big problem. We have to leave the app. So if you want to share an article in the FT app, you have to leave the app, go to Twitter, go to Facebook, sign in, get your token, come back, and then we reboot the whole app again. The reason we have to do that is because typically these social media networks don't let you load their login pages in iframes. And there's a very good reason for that, because in CSS we could make that iframe completely transparent, and we could put something tempting in front of the button, assume that the user's browser will autofill the username and password, and then get them to click on the button without realising it. That's called clickjacking, and Twitter and Facebook both take steps to make sure that it doesn't happen. So as a result, you can't load their login pages in iframes. Offline adverts is still an issue for us. We currently don't serve ads offline. But if you think about it, the way that ads have been sold digitally over the last 10 years has evolved into a kind of really finely tuned, finely honed machine for selling impressions and clicks. And these concepts don't really work when we can't measure the behaviour of the user in real time. We can't pull an ad. We can't click an ad and have it advertise this website load because there's no connection. So what's going to happen when we click the ad? Nothing like that. And automated QA has been a real struggle for us as well. It's easy enough when you can use tools like Selenium to automate a desktop browser, so you can say perform these actions as if you're the end user and this should happen. It's much more difficult to do that on a mobile device, and particularly if you're supporting a very wide range of mobile devices, to attempt to instrument those devices and perform automated QA is very, very difficult. So at the moment, although we're developing some techniques in this area, we still have a lot of manual testers with a lot of devices. In fact, our team currently is outnumbered by devices, about 5 devices to each person. There are some really useful tools that will help if you're starting to embark on something like this. First of all, get yourself a web debugging proxy. Charles is a really, really good one, and I don't have any reason financially to endorse any of this stuff. But Charles Proxy is really, really good piece of software. You put it in the middle of your requests from your device to the server, and it will literally list all of the conversation that's going on between the device and the server, everything you ever want to know about the requests, headers, request headers, response headers, request body, response body, cookies, breaks down any JSON response that allows you to navigate the tree. Really, really useful. And it can even do breakpoints, so you can tell it to change certain things about the request or the response. Tools like this will also allow you to do things like simulate 3G networks. So a 3G network will typically be very good bandwidth, but very, very high latency. So simulate that. Make sure that you're always working on a connection that's similar to the kind of connection conditions that your user will be experiencing. Winery is a really, really good tool for connecting a web inspector to your device. If you're building a website on a desktop, it's a no-brainer. You use a browser that provides you with a really good web inspector like Chrome Developer Tools. On a mobile device, you just don't have that available. So what can you do? With Winery, you can put a JavaScript library into your page, and then you can just fire up a desktop app, and it will connect to your device as if you're running a web inspector on the device itself, which is really useful. Incidentally, on Playbook and on the recently released Chrome Beta for Android, the developer tools are natively supported. So all you need is an instance of Chrome running on your desktop machine, and you just type in the IP address of your device, and you get developer tools as if you're connected, and you are connected directly to the device. WebDriver is a means of automating actions in a browser, and there is now a WebDriver mobile project which allows you to automate actions within Safari for iOS, within an Android browser as well. So in summary, the reason we came up with native apps as a solution to the problem was because the problem existed that websites were difficult to use on mobile devices. So ease of use is clearly critical, and the web didn't adapt quickly enough to become the initial technology of choice to solve the mobile interaction problem. But now we can. Web technologies provide now all the tools that we need to solve these problems, and it can provide significant benefits over and above using native apps. So I was at a conference last year. I had the opportunity to ask a question of Tim Berners-Lee, and he gave me the very quotable response: "Don't build native apps, build web apps." And that's all for me. Anyone